Hey everyone, today we're going to do lesson 1 of Unit D. We're going to be identifying initial values. This first question asks us how we can tell if a relationship is linear from looking at a graph or from looking at a table. When we're looking at a graph, we can see if it's a linear relationship because the graph will show a straight line. If we're looking at a table, we'll have to do a little bit more calculating or digging to determine if it's linear. We'll need to look at how the dependent side is changing and how the independent side is changing. If there's a consistent increase or decrease in each of the sides of the table, then we'll know it's a linear relationship. Remember that when we calculate the changes on the right side of the table or on the dependent side of the table, we find the rise. And when we calculate the change in the numbers on the left-hand side of our table, we're calculating the independent change or the run. This question asks us what an initial value is and asks us to draw a sketch of a graph to show an initial value. The initial value is the starting value of the graph. We can think of that word initials like the initials of our names or the first letters of our name. So the initial value is going to be the first value on the graph. We can find it when the independent value is 0, and that's going to place the point along the dependent or the y-axis or vertical axis of the graph. The initial value could start high on the axes and then the line could go down, or the initial value could start lower on the axes and then the line could go up from there. This question asks us what the difference between partial and direct variations would be. We know that whether something is partial or direct variation depends on its initial value. A partial variation starts at anywhere that's not 0, where a direct variation will start directly at 0, 0. This question asks us how we will find the initial value in a table. The initial value in a table can be found first by determining where 0 occurs on the independent column. So if we look at the table and we find where 0 is in the first column, then the number that's directly beside it will be our initial value. If we think about how this would look on a graph, when we would go 0 over and then up a certain number, that would place a point on the y-axis or on the dependent axis. This would be our initial value. Finding the initial value in a table can sometimes be a little bit tricky because people assume it's going to be the first point inside the table. That's not necessarily true because if a table started at, say, -2 and then -1 and then 0 in your independent column, then you again would have to be careful to find where 0 is so that you can find the number next to it in your dependent column to know what the initial value would be. There may also be situations where we're given a table that doesn't have 0 in it at all. We would then have to look at the pattern in the independent column to try to help us figure out where 0 would occur. So we might have to count back up or even down farther to find where 0 would be. And then again, the number next to 0 would be your initial value. Question number 5 asks us to give an example of an equation for both a direct and a partial variation, and then to label the parts of each equation. Let's begin with an example of a direct variation. Let's look at the equation C equals 75H. This is an example of a direct variation because there is no initial value listed. The initial value would be 0, which is exactly what a direct variation means. If we look to label the parts of our equation, C could be representing the cost, maybe of getting a computer fixed, and 75 would be the rate of change. Perhaps it's $75 per hour that the computer takes to get fixed, and H would be the number of hours. The initial value, again, would be 0. So we would have our dependent variable C equals the rate of change 75 times the independent variable H, which is the number of hours, plus the initial value, which in this case would be 0. Our second equation could be representing a partial variation. Perhaps we'll use the equation B equals -50W plus 800. In this case, it might be the balance of a bank account, or the dependent variable, is equal to negative 50, which would be the rate of change. Perhaps that's negative $50 per week. W would be the independent variable, perhaps for the number of weeks. And then our initial value would be 800, perhaps the amount of money that began in the bank account. If we draw a sketch of this situation or this partial variation, we would need to have dependent variable being balance, or the amount of money in the bank account. Our horizontal axis or independent axis would be time in weeks. And then as we sketch our graph, we would begin at $800 in the balance. That would be our initial value. And then we would go down every week by $50. In our table, we would begin with a table set up with our independent being weeks. Our first column would be weeks, and our second column would be balance. For the initial value of 0 weeks, we would have $800. And then for every week that passes, we would be decreasing that $800 by $50 every week. And there you have it, a partial variation with a table, a graph, and its equation. Good luck as you practice identifying initial values.